Mutually exclusive events. First thing I notice when I see this slide is I'm noticing up in the top right, it's different than the independent and dependent events because there's a little word that's a little different right there, and that's the word or. Or is going to tell me that I'm going to add down here. Whenever I see and, I'm going to multiply. Whenever I see or, I'm going to add. Mutually exclusive events. Events are said to be mutually exclusive if they don't occur at the same time. There's no common outcome. What does that mean? Well, we'll see here in a second. A pair of dice is rolled. Sorry, I said dice. Number cube. Number cubes are rolled. What is the probability that the sum of the dice, sorry about that again, rolled is either a 7 or a 2? Well, how can I roll a 7? Well, I could roll a 1 6, 6 1. I could roll a 2 5, 5 2. I could roll a 3 4. That's kind of a 4 and kind of a 3. And is that it? I think that's it. It's all the ways I could roll a 7 if I have two number cubes. Ways to roll a 2. Well, how can I roll a 2? 1 1. That's it. Nothing else. So, what's the probability I can roll a 7? Well, yesterday or the other day we talked about when I held the two number cubes up, and we talked about how many total options there are when you throw two number cubes. How many total options are there? 36. So, what's the probability I roll a 7? That would be, 1, 2, 3, 4, 5, 6 out of 36. Plus, ways I could roll a 2? Only one way out of 36. Final answer would be 7 out of 36. So, ways I could either roll a 7 or a 2, or means to add 7 out of 36. A bag contains 6 red cards numbered 1 to 6 and 5 blue cards numbered 1 to 5. What's the probability of choosing a red card or a blue number 4 card? So you imagine you've got this bag, there's 6 red cards in there, and then there's 5 blue cards in there. What's the probability of choosing a red card? Well, how many total cards we got? We got 11 total cards. How many of them are red? 6. Or means add. A blue number 4 card. Well, how many blue number 4 cards are there? 1 out of 11. That's 7 out of 11. That's the probability you would choose a red card or a blue number 4 card. Next one, bag contains 4 brown cards numbered 1 to 4 and 7 blue cards numbered 1 to 7. What's the probability of choosing a brown card or a blue odd number card? Well, how many total cards we got? 11 total cards. And then probability of choosing a brown card would be 4 brown cards. Or means to add a blue odd numbered card. All right, so we got 7 blue cards and they're numbered 1 to 7. How many of them are odd? Well, 1, 3, 5, 7. That's 4 of them. So the odds that or the probability that we're going to pick a brown card or a blue odd number card would be 8 out of 11. Okay. I got a teacher who has 9 red crayons, 4 blue crayons, 7 purple crayons, and 5 black crayons. A student reaches into the basket and randomly selects a crayon. What's the probability that the crayon will either be blue or black? How many total crayons I got here? 13. I think I got 25. Is that right? 25 total crayons. And we want a blue crayon. That's 4 out of 25. The word or means to add. Black. 5 out of 25. So the probability that we get a blue or a black one would be 9 out of 25. Okay. Next one, teacher has 10 red, 8 blue, 2 purple, and 5 black crayons in a basket. A student reaches into the basket and randomly selects a crayon. What's the probability that the crayon will either be blue or red? Something, just want to remind you, we were talking about independent and dependent events the other day, and it's like multiple events are happening, we're going to multiply. This is just one draw out of the bag. This is not multiple events. This is a single event. What's the probability that a crayon will either be this, blue or red? We're just taking one crayon out, and we want to know, is it going to be blue or red? So we're going to add right here. 4 means add. Okay. Total crayons, 18, 20, 25 total crayons. And how many of these are blue? 8. Plus, how many of them are red? 10. That would be 18 out of 25 would be your answer there. 18 out of 25. Okay. What I want you to do, I want you to push pause. I want you to try these two and then come back here in just a second. A teacher has 6 red apples, 4 yellow apples, 2 green apples in a bucket. Maria, the creepy person from Independent and Dependent Events, is following her around again. She will choose 1 apple from the bucket. What's the probability that Maria will choose a red apple or a green apple? Or means to add. How many total apples I got in there? 12. And a red apple would be 6 of them. Or was to add. There's 12 apples in there. Green would be 2. That would be 8 out of 12. You punched in your calculator and it told you 2 out of 3. We got 12 red apples, 3 yellow, and 5 green apples in a bucket. Maria, the creepy person, is following around. And what's probably that Maria will choose a yellow apple or a green apple? So how many total apples I got there? 20. And yellow would be 3 of them, right? Or means to add. A green apple would be 5 out of 20. That would be 8 out of 20. Your calculator told you 2 out of 5, I bet. Woo, that is a tough 5. Questions? You can't. You can't ask me. All right, let's look at the next set. So the thing that goes with mutually exclusive is overlapping. Notice it still says or up here. We're still going to be adding. Still going to be adding. Events are said to be overlapping if they occur at the same time. We're going to see what that means here in a second. So I've written this out for you the first time. You don't necessarily have to write this red and blue and all the numbers out, but I want you to see what overlapping means. So a bag contains 6 red cards numbered 1 to 6. I put them all right there. And then 5 blue cards numbered 1 to 5. Drew them out down there for you. What's the probability of choosing a red card or an odd number card? Well, I got or. I know I'm going to add. How many total cards do I got? 11. What's the probability of choosing a red card? Well, I've got 1, 2, 3, 4, 5, 6 red cards. Or means add. An odd numbered card. Well, how many odd number cards I got? Notice how I draw this. Notice how I write this. 1 odd number, 2 odd number, 3 odd number, 4 odd number, 5 odd number, 6 odd numbers. That's 6 odd number cards. What do you notice? We marked some of them more than one time. How many did we mark more than once? How many overlapped? 3 of them. That one did, that one did, and that one did. We don't want to count them twice, so then we're going to subtract the overlap. We we marked out 3 of them twice, so I'm going to subtract those. I think you get 9 out of 11. So, given these, you can write it out if you want to. This one says yellow cards and green cards. You can do just like what I just did on that last one, writing this out, red and blue like that if you want to. If that helps you, by all means. At some point, you're going to have to get past that and just figure it out. But if you need that to start with, that's fine. A bag contains 4 yellow cards numbered 1 to 4. 5 green cards numbered 1 to 5. What's the probability of choosing a number 3 card? Well, how many number 3 cards do we got in the bag? 2 of them. One of them's yellow, one of them's green. So 2 out of, I think there are 9 total cards. Or means add. A green card. How many total green cards we got? 5. Okay. Is there any overlap? Yes. Are there number 3 cards that are green cards? Yes. How many? Just 1. That would be 6 over 9. I think you get 2/3 when you punch in your calculator. A bag contains 6 red cards numbered from 1 to 6 and 5 green cards numbered 1 to 5. What's the probability of choosing an even numbered card or a number 4 card? All right, so we got 6 red cards, 5 green cards. What's the probability of choosing an even number card? We got 11 total cards in there. And then an even number. All right, so think about the 6 and then the 5, even number. So I got 2, 4, and 6. And then green cards, I got 2 and 4. So that would be 5 total even numbered cards. Or means add. A number 4 card. How many number 4 cards we got? Well, there's one that's red, there's one that's green. Plus 2 of them. And then I'm going to subtract. Any overlap? Hey, are there even numbered cards that are number 4? Yeah, both of them are. That would just be 5 out of 11. Okay. In Coach Briscoe's class, there are 12 boys and 16 girls. On Thursday, 4 boys and 5 girls were wearing UGA jerseys. If a student is chosen at random from Coach Briscoe's class, what's the probability of choosing a boy or a student wearing a UGA jersey? Okay. So how many total people we got in the class? 28. And we want the probability of choosing a boy. How many boys we got in the class? 12. Or means add. A student wearing a UGA jersey. Well, how many students are wearing UGA jerseys? 9 total. Okay. Now, is there any overlap? Are there boys that fall into this group of students wearing a UGA jersey? Yes. How many boys are wearing a UGA jersey? 4. Minus 4 out of 28. That would be, I think, 17 out of 28. Okay. If a student is chosen at random from Coach Briscoe's class, what's the probability of choosing a girl? How many girls we got? 16 total girls out of 28. Or means add. A student not wearing a UGA jersey. If we have 9 students that are wearing UGA jerseys out of 28, how many are not? Well, you say 28 minus 9. That would be 19 out of 28 are not. Now, are there girls that are not wearing a UGA jersey? Yes. How many girls are not wearing a UGA jersey? Well, we got 16 total. 5 were. That means that 11 were not. So that would be what? A 24 out of 28? Hopefully. Mental math is correct. And that would be 6 out of 7. Okay. Next. Make sure you write small on this one. Tommy has a number cube with sides labeled 1 through 6. He rolls the number cube twice. What's the probability that the sum of the 2 rolls is a prime number or means add? At least one of the rolls is a 3. So previously we talked about conditional probability and where, hey, at least one of the rolls is a 3. And we wrote all of the ways you could roll 2 number cubes out. And we circled all the 3s and said, hey, let's not write all this every time. Let's just write the ones with a 3. So we're going to do that here in a little bit. What's the probability that the sum of the 2 rolls is a prime number? Well, we need to write all the ways I could get a prime number. So let's write prime. Prime number, or means add. At least one of them is a 3. And then we're going to subtract the overlap. I know that looks pitiful. Whatever. Prime numbers. All right, prime numbers that we could roll with number cubes. I could roll a 2. I could roll a 3. I could roll a 5. I could roll a 7. I could roll a 11. Is that the next one? And that's it. And I need to write all the ways I could do that. So, how could I roll a 2? I could roll a 1, 1. How could I roll a 3? 1, 2, 2, 1. How could I roll a 5? 1, 4, 4, 1, 2, 3, 3, 2. How could I roll a 7? 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 3. And how can I roll an 11? Just 5, 6, and a 6, 5. Okay. I'm going to make that a little bit smaller right here. Hopefully it will work out. Okay. This is the way I can roll a prime number. Next. It says at least one of the rolls is a 3. Well, we did this the other day where it's, whoa, where at least one of the rolls is a 3. So I got what? 3, 1, 3, 2. 3, 3, 3, 4, 3, 5, and 3, 6. But I also got 1, 3, 2, 3. Not going to write 3, 3 again. 4, 3, 5, 3, and 6, 3. Okay? So, how many ways could I roll a prime number? I know that's a lot of writing. You push pause, all that kind of stuff. So, how many ways could I roll a prime number? I'm counting over here on the left side. 1, 1 would be 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36 ways to roll a prime number. Or means add. How many ways could I roll at least one of them a 3? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 36 ways to roll at least one of them a 3. Now we need the overlap. The way you do the overlap is you say, well, all of these have a 3 in them. So I need to mark out all the ones with a 3 on the left side. So I'm going to subtract 1, 2, 3, 4 out of 36. And you'd punch all that in your calculator. It would give you, I think, 11 out of 18.